Hi. Thanks for for giving me the possibility of presenting this project, which is about FIES and the Gaia Benchmark stars. So this project is the product of a big collaboration. Therefore, I'm speaking on behalf of many other scientists that could not be here today. And I joined this project while I was doing my studentship at NOT, since I observed some stars of this sample with FIES. So a little bit of context. Yes. Okay. So what is the Gaia sample, Gaia benchmark star sample, and why it's important? So we are now in the era of the large spectroscopic survey. So we have a wide amount of stellar parameters, chemical abundances, and we are facing also very interesting new release. But it has also been shown that the results that we are deriving from this different data set often show differences, both in the determination of stellar parameters and both in chemical abundances. Therefore, it's crucial to have a validation sample that we can use to calibrate all the new spectroscopic surveys that are coming. And for this reason, this validation sample that was called as Gaia FGK benchmark star was created in 2014. The initial data set was composed of 35 stars, and that for which the stellar parameters, so temperature and gravity, were derived independently from spectroscopy. So basically, were derived using fundamental relations. For this set of stars, it was known the angular diameter, the parallaxes from the Hipparcos sample, and bolometric fluxes. And then using the relation of the Stefan-Boltzmann law, the temperature could be derived, and the luminosity. And once known the temperature and the luminosity, the mass of the stars was driven by using evolutionary tracks. And finally, the gravity was computed using the gravitational laws. And you can see in the plot the Kiel diagram for the initial set of stars with color-coded by metallicities. And basically, deriving this parameter, the derivation of this parameter independent from the spectroscopy information enabled to have an high accuracies on the iron and other chemical abundances. Indeed, it was found that the dataset was lacking of stars with metallicities below -1, so the metal poor stars that we saw just in the talk, the previous talk, how they are important. And also the sample was lacking of some main sequence stars and dwarf. Therefore, a new compilation was built, and also the parallaxes were then derived from the Gaia mission. Right now, we are working on the last and on the most update version of this catalog that it's composed of about 200 stars, to be precise 196. And this last sample was is still taking some stars from the previous sample, but we have applied some criteria to clean this final sample. So we removed some mirrors, binary stars, and especially we tried to get rid of all the stars for which we had higher uncertainties on angular diameter or photometry. And we still add some metal poor stars from latest compilation. So right now, the final sample is shown in the color magnitude diagram on the right. And for all these stars, we have also parameters and iron abundance from the pastel catalog, which is a bibliographic catalog that contains stellar parameters and iron from high-resolution measurements. And also the novelty of this last sample is that we are trying to calculate or compute using a spectral energy distribution fitting our own volumetric fluxes and then determine gravity and mass using stellar evolution code. This sample of stars is spread among, is on both hemispheres, and you can see that covers a wide range of magnitude, arrive till 10 magnitude in the V band. But how FIES took part in this work and why it's important to have the possibility of observing this star with FIES. So half of this sample has high-resolution spectroscopy from public archives. Therefore, we can query spectra from HARPS, FEROS, UVES, and all the other instruments that you can see here in the histogram. And among all these spectra, we have 53 that come from FIES. And among these 53 spectra, most of them are just present or are just provided by FIES. Therefore, were really crucial in our analysis. Indeed, with all the spectra collected, we aim to create a homogeneous spectral library. So to be able to have, for all the spectra, chemical abundances, stellar parameters, and iron that are homogeneous for the stars that can be observed with different instruments. So what we expected is that this difference, for example, of the iron abundances that we are computing thanks to our stellar analysis with the iron abundances present in pastel is reduced as much as possible. So of all the stars that we have, of the 200 stars, 19 were observed with FIES, and 13 of them are just provided by FIES. And here is an example of spectra with analysis for the FIES stars on the left, and the same analysis for stars observed with HARPS. And you can see that with FIES we have a very good agreement in, for example, in the derivation of iron, and compared, for example, to the data from a bigger telescope. And this to say that all the data that we collected were high quality. And from my perspective, apart from the analysis part, when I start to observe this Gaia Benchmark star, with FIES was a perfect experience because was connected the observation part plus a science project that, it introduced me then to a very interesting science project. And however, this is a work in progress because there's still much work to do to make this sample